get third, fourth grade. Some of these are going to require you to use the formulas, but some of them will be easier. So I actually need to flip this over. Let's see. It's just my laptop hooked up. It doesn't work as well as I would like for it to. I want them to get me something better, but this is better than nothing. So a sequence is a list of numbers formed using some type of pattern. So, for example, 3, 6, 9, 12, and so on, right? Or 1, 2, 4, 8, 16. These are patterns. In the first pattern, you're just adding 3 each time. In the second pattern, you're multiplying by 2 each time. So it's a list of numbers created using a pattern. That stuff you've been doing since you were small. A series is just a sum of a sequence. So rather than having 3, 6, 9, 12 as a list, it's 3 plus 6 plus 9 plus 12 and so on. So that's a series. That's the difference between the two there. So the two types of series and sequences that we're going to focus on are arithmetic and geometric. So the first we're going to talk about is arithmetic, which looks like arithmetic, but usually I hear it called arithmetic whenever someone is talking about a sequence. So arithmetic sequence is a sequence formed by adding a constant to each successive term. That just means a pattern where you're adding or subtracting the same number over and over again. That number that you're adding or subtracting is your constant, common difference. So, for example, back there on this sequence right here, the 3, 6, 9, 12, that is an arithmetic sequence because you're adding 3 each time. The common difference is 3 in that case. So it's really very simple. It's just making sure that you know make sure you know the language that goes with it, the vocabulary, because you might get a question like find the common difference for this problem. So for example, this first one, we've got 2.5, 0.8, negative 0.9, negative 2.6, and we're supposed to find the common difference and give the next 3 terms. So for this, if we're looking for common difference, this one's a little harder to just see, but you can always just take a term and subtract the term in front of it. So if you were to do 0.8 minus 2.5, you get negative 1.7. And then if you just see, like if you have 0.8 and you subtract 1.7, that'll give you negative 0.9. And if you subtract 1.7 again, you'll get negative 2.6. So your common difference, which I'm going to denote with a D right here, is negative 1.7. And then if we need to find the next 3 terms, we're just going to subtract 1.7 3 times. So we'll have negative 4.3. We'll have negative 6. And we'll have negative 7.7. Okay, questions? All right, for the next one, we don't have numbers. We've got like variable expressions here. So we start with x. We've got x minus 4, x minus 8, x minus 12. What is being subtracted each time? 4, right? So the D there is going to be negative 4. It's negative because you're subtracting the number each time. And so for the next ones, we're going to have x minus 16, x minus 20, and x minus 24. Okay, any questions so far? All right, let's look at the next slide. Okay, so this is a little bit different. Recursive formulas in Math 1, you use recursive formulas for arithmetic and geometric sequences, which we can still do. But if you find a recursive formula on the pre-cal exam, it's probably going to be a little more complicated than just like a sequence or a series where we're adding plus 2, plus 4, plus 5, plus 6 there. So recursive formulas when you did them in Math 1, I'm not sure. Let's see. You guys had Miss Swisher. Some of you had Miss Swisher. Some of you had Miss Ball. If you had it up here, you had Miss Ball. If you had it in 8th grade, you had Miss Swisher. Is that right? And so I don't remember if we had changed Math 1 yet. When you guys did recursive formulas, did you do like next equals now plus 7 and starting at 23? Did you ever use any of this notation, a sub 1, a sub 2, a sub 3? Allie says yes, but a lot of you are saying no. Okay, I think probably you guys were the year that they switched from one to the other, so it just depends on where you've seen some different stuff where they may have put this. So, a sub 1 would be your first term. A sub 2 is your second term. I really should, like, your start value is usually, they'll tell you, is a sub 0. So it's just where it's at in the list, the first, second, third, fourth, fifth, sixth in the list. A sub n is the nth term, and a sub n minus 1 is the term that comes before that. So this term right here is your next, if you did the next now, and this is what you've got right now. So if you kind of think about this, if a sub n is a term that you have, a sub n minus 1 would be the one that came right before your a sub n. It's possible you might see an a sub n plus 1. If you saw that, it'd be the one that came right after n. So they might ask you to write a recursive formula. Typically they don't. Typically they give you the recursive formula and then ask you to tell what the next number is or something like that. But if you're asked to write a recursive formula, so we've got -3, 7, 17, what are we doing each time to get to the next value? Okay, we're adding 10, right? So if you only look at the y's, we're just adding 10 each time. This next one right here, you'd have 27. So if I'm going to write a recursive formula for this, if I'm doing the way that most of you did in Math 1, you'd say the next number equals what you have right now plus 10. And you start at -3. Right? So that's how you would have done it in Math 1. I like that. It's one of the few things that Core Plus book does that I like because it makes sense. You take the number you got now, you add 10 to it, it gives you the next number. It just kind of makes sense the way it works. So with recursive notation, it looks a lot weirder and scarier, but it's the same thing as what you've done here. So for this, if I want to know a term, if I want to know an a sub n, I would take the term before a sub n, and the term before a sub n would be a sub n minus 1, right? And I would add 10 to it. And then my starting value is my a sub 0, and it is -3. So at this point, any recursive formula we write's got to be written with that formal recursive notation where we have the a sub n's and a sub n minus 1s and all of that. Okay, questions? All right, if we look at the next one, we've got 2, 3 halves, 1, 1 half. What are we doing each time here? We're subtracting 1 half, right? So if we want to know a term, an a sub n, we're going to take the term that came before it. What do I write for the term that came before it? A sub what? N minus 1. And a sub n minus 1, we're going to subtract 1 half. And our a sub 0 here would equal 2. That start value is your a sub 0. Okay, questions? Let me show you one more thing because it's hard for me to know. Most of the stuff I've dealt with always has an a sub n formula. Sometimes you see formulas that might look like this. A sub n plus 1 equals, so if I'm going to use a sub n plus 1 this time, what's the term that comes before a sub n plus 1? A sub n. So a sub n minus 1/2. And then a sub 0 equals 2 for that. So it just depends on how they've written the formula. You might see something weird like this. So think about your n's. If you got a plus 1, it means that you got the next value. If you got a minus 1, it's the one before the value. So kind of think about those when you see these. I don't think they're going to have any on there that you have to write the formula for, and they have to do it multiple choice, so you can always work your answer choices backwards. But you might see something like this. What I think you're more likely to see is what's on the next slide. I think that they are more likely to give you a problem like this, where you have a sub n equals a sub n minus 1 plus 3n minus 1, and they tell you the first term is 2, find the next 4 terms in the sequence. This is what I think you're more likely to see. And they said first term, since they called it the first term, not the 0 term, I'm going to say that a sub 1 equals 2. And actually, we may only find the next, let's just find the next 3. It gets a little bit long if we find the next 4. So for a recursive formula, you're going to do like you do for any other formula. I've already got a sub 1. Now I need to know a sub 2. Right? So I'm going to say a sub 2 equals. And I'm going to plug in 2's everywhere there's an n. So I'm going to have a sub 2 minus 1 plus 3 times 2 minus 1. So everywhere I see an n, I plug in a 2. And when I do a sub 2 minus 1, that gives me a sub 1. Plus, I'm going to go ahead and do this as 6 minus 1. What is a sub 1? It is 2. And then we've got plus 6 minus 1, so that's plus 5. So we get here that a sub 2 is going to equal 7. So here was a sub 1, here's a sub 2. Now we've got to find a sub 3. So for a sub 3, we're going to take that formula, we're going to plug in 3 for all the n's. So we're going to have a sub 3 minus 1. What was the formula? Let me scroll back up there. Plus 3n, so plus 3 times 3 minus 1. And so I'm going to kind of do this in my head a little more than I did the last one. What is 3 minus 1? It gives us 2, so that means we're looking for a sub 2. What was a sub 2? It was 7. So we've got 7 plus 9 minus 1. And when we do that, we're going to get a sub 3 equals 15 for that. So this will be our next one here. So we were given the first one. We found the next 2. Let's find one more, okay? So if we're finding one more, we're looking for a sub 4. So that's going to be a sub 4 minus 1 plus 3 times 4 minus 1. And so a sub 4 minus 1 is a sub 3. A sub 3 is 15 plus 12 minus 1. So that's going to be 27 minus 1. So we get a sub 4 is 26. Okay, questions? Okay. All right. So let's look at arithmetic sequences in particular. Okay. So an arithmetic sequence is just something where you're adding a number each time. So let's just do this first. Ignore that formula. So we've got this sequence, -3, -1, 1, and so forth. This term right here, let's call this our first. This is our first term. That's your second term. That's your third term. All right. I want everybody to find me the 43rd term in that sequence right now. Just knowing what you know, like you're in the second grade. Find me the 43rd sequence number in that sequence. So. Oh, will that not go away? Okay. All right, so everybody find it on your own. You, of course, may use your calculators. Okay, when you get it without telling anybody your answer, write it down. Because I want to see how many of us got it right. Okay, everybody got an answer? Okay, the correct answer is 81. How many of you had 81? Raise your hand if you had 81. Okay? How many of you did not have 81? Okay? It is so easy to, what you should have done there, and I think most of you were, is you start at -3 and you just keep adding 2 over and over and over and over again 43 times. The problem with it is it's really easy to make a mistake when you got to add it 43 times. So the good news about these problems is that if you see this on the exam and you can't remember what to do, you can add 2 43 times. Or actually, I guess it's 43 times because the first one is already there. But you can add that many times. And you can get the right answer. And, you know, over half of you got the right answer doing that. So that works. But it also has a lot of room for error because all you got to do is hit the button twice on accident or not count one of the ones that you are supposed to be counting and you got the wrong answer. So we have this formula up here, and this formula is on your formula sheet. Oh, I've gone to the wrong thing. Okay, so this formula is on your formula sheet. A sub n equals a sub 1 plus a sub n minus 1 times d. So if you need to find any term, you're going to take your first term and add n minus 1 times d. If you think of what you just did, if you found it by hand there, you added 2 42 times, right? Because it was 1, you already had the first term, so you added it 1 less than the term you were looking for. So if we did this with the formula, then we would do a sub 43 would equal a sub 1 plus 43 minus 1 times our d. A sub 1 is your first term, which would be negative 3. You'd have 42. And then the d is the common difference. It's the number you're adding each time, which in this case was 2. So if you do negative 3 plus, this is going to give you 84. That gives you 81. And you'll have this formula sheet on your test that you'll take for me, plus on your final exam. So you don't have to have it memorized. You do need to know what everything stands for because, of course, that's not given to you. But this takes out some of that room for error. But you don't have to use it on a problem like this. However, on a problem like 6, you could still do it without you could still do this problem without the formula, but I think the formula makes this one a lot easier. So we've got the sequence a sub n equals a sub n minus 1 minus 2/3. If a sub 19 is 42, we're supposed to find a sub 1. So the first thing I need to know is for this sequence, what is the common difference? Whenever we're looking for that, we will look right here at the recursive formula that they give us. Okay, so that formula is like saying the next number equals what you have now minus 2/3. So what are you doing each time to get to the next number? Subtracting 2/3. So what's the common difference? Negative 2/3. That number you're subtracting each time is your common difference. So D here is going to be negative 2/3. So the only other thing we have is that a sub 19. So a sub 19 would equal, if we're using that formula, it would equal a sub 1 plus 19 minus 1 times negative 2/3. Okay, and what is a sub 19? What does it equal? 42. So I put 42 here. 42 equals a sub 1 plus, this is going to be 18 times negative 2/3. What is 18 times negative 2/3 there? Negative 12. Okay, we want to know a sub 1, so we would add 12. And so we'll get 54 for our a sub 1. Okay, that's not the only way you could do the problem. You could have started at 42. If the common difference is negative 2/3, that means you're subtracting 2/3 each time. In this case, you need to go from 19 back to 1, so you got to go backwards. So instead of subtracting 2/3, you'd add 2/3. So you could start at 42 and you could add 2/3 until you get back to a sub 1. But to me, I have a hard time counting backwards for that, and it's a lot easier to use the formula for me. But you don't have to necessarily. You could also check your answer on this by starting with 54 and subtracting 2/3 18 times until you get to the 19th term to see if you do get 42. And you will for this one. Okay, questions? Okay, so that's for arithmetic sequences. We also need to know about, no, hold on. We've got to do a different problem. I'm skipping ahead of myself here. All right, so in this particular case, to encourage aggressive sales, you are paid $3,750 for the first house you sell, then $4,250 for the second, and $4,750 for the third, and so on. So in this case, the amount that you are paid for each house increases each time you sell one. Now, if you're really going into real estate, you get paid a commission, so you get paid a percentage of whatever the house sells for, basically. But perhaps this could be something where maybe you're selling like condos in a building that are all the same, you know, where this might be something that they want to do. So this would be sort of specialized, but this, and you could definitely think, you know, sometimes you might be like, well, you know, I've already sold 10 houses, and so what's another $1,000 for this house I'm going to sell? But if you're getting paid more for each house, you're like, oh, if I just sell one more, that's like $5,250, right? So each time you want to sell more, because the higher you get, the more money you're making off of each one. So you can see how this would encourage some aggressive sales. So in this case, we want to know how much money you make if you sell 15 houses. Okay? So that's the total amount, not just how much you make for the 15th house, but how much you make for selling all of them together. So you could do this the long way. You could take $3,750 plus $4,250 plus $4,750 plus $5,250 plus $5,750, and so on until you got 15 houses, right? So you could do this the long way, and you can definitely do it this way. But there's also a formula that can help us here, and that formula is the second one underneath your arithmetic sequences there that says capital S sub n. All right, and so that capital S sub n is the sum of a finite arithmetic sequence, or sometimes called a partial sum. Okay, it's called a partial sum because you're not adding the series. The sequence goes on and on and on and on forever. We don't want to know the sum as it goes on forever, because it would be infinity in this case. We want to know just the first 15 terms. Okay, so for this, what you'll do, if I want to know the sum of the first 15 terms, then that would be 15 divided by 2, and then I would do a sub 1, which was 3,000, what was it, 3,000, let me get to the right, 3,750, plus a sub 15. Oh, I don't know a sub 15. But I could use my other formula to find a sub 15. So if I did that, I'm going to go up here because I'm running out of room. A sub 15, can't write small on this thing. A sub 15 would be a sub 1, which is 3,750, plus 15 minus 1 times, what's the common difference? What number are we adding each time? 500. And so whenever you do that, 3,750 plus 14 times 500 is going to give you 10,750. Okay, so that a sub 15, we could make that 10,750. All right, so in your calculator, you can do this. You'll have 7.5 times 3,750 plus 10,750. And whenever you do that, you should get that you would make 108,750. Are these for... Okay, I see the names. Okay, yes, thank you. Okay. All right, so that's some pretty good money, I feel like, for your selling of your houses. Plus, you got like an extra $10,000 for that 15th house. There was a lot of incentive to sell that 15th house, right? And if you could just get the 16th, it'd be even higher. So you can see how that would work. Let's say you feel like, though, $108,000 is just excessive. You don't need that much money, so you're not going to work that hard, right? Let's say that you want just to make $65,000. That would be enough. That's going to pay your bills. You don't want to work any harder than you have to right here. So if $65,000 is enough for you, that's the sum that you want to have, right? So you would have in that formula that S sub n equals n over 2 times a sub 1 plus a sub n. You would say 65,000 equals, we don't know what n is. We're going to put n over 2 times a sub 1 we know is 3,750. And we do not know a sub n. Okay, so in this case, you can't solve this right now because you got an n and you've got an a sub n. But we have another formula for a sub n. We know that a sub n equals a sub 1 plus n minus 1 times d. So what we're going to do is we're going to take our 6,500 or 65,000. 65,000 is going to equal n over 2 times 3,750 plus, and then a sub n equals a sub 1 plus n minus 1 times d. Right, and I know a sub 1 and I know d, so I could plug those two things in. So that would give me 65,000 equals n over 2 times 3,750 plus 3,750, because that's a sub 1 again, plus I've got n minus 1 times 500. Now, it looks pretty complicated, but this is better, at least, because now the only variable you have there is n. So we can solve this equation for n. So I would start by combining that stuff in the parentheses. I could say, let's see, 65,000 equals n over 2 times, if I add that, those two there together, I get 7,500. Plus, I also could distribute that 500, so that'll be plus 500 n minus 500. So I could put the 7,500 and the 500 together, so 6,500 equals n over 2 times 500 n plus 7,000. Okay, what am I going to do from here? Any ideas? Let me write this a little bit differently. That n over 2 makes it kind of weird. So 65,000. This is the same as 1/2 n. Or actually, let me even do this. Since it's going, any of this is going to be calculator active. If it 1/2 n is like 0.5 n, right? And then 500 n plus 7,000. What would you guys do with it looking like that? You could divide by 0.5. You want? I probably would have done it differently, but it'll work, which is going to double that, so that'll be 130,000. what would we do now? Distribute that in. And I probably would not have divided the 0.5 off. I probably would have went ahead and distributed, but it either way doesn't really make a difference. It'll, you know, it doesn't really make a difference at all. So we'll get 500 n squared plus 7,000 n. How do I solve this? A lot of times I find this is where we fall apart, the Math 1 stuff. What type of equation have we got here? Quadratic. And for quadratics, we move everything to one side, right? So let's move everything to one side. We'll have 0 equals 500 n squared plus 7,000 n minus 130,000. Now, I could try to factor this or do quadratic formula as it is right now, but I feel like everything's going to divide by 500. And my life will be a little bit, sorry, it's not. My husband's got to take my son to the doctor later. Got that out. But so everything will divide by 500, so we'll divide by 500. And you don't have to do this step. It's just going to make your numbers smaller so they're easier to deal with. So you're going to have 0 equals n squared, let's see, 7,000 divided by 500. It's going to be 35, 14, close. All right, equals 14 n minus 260. Oh, wait, that right there's a plus, not a equals. 260. And let's see. This one will not factor. So it will not factor. So let's just use quadratic formula. Or you can complete squares. This one wouldn't be bad to complete. I'm going to complete square. I like it better. So n squared plus 14 n plus blank equals 260. Move that because this is like it equals 0. You're moving it to the other side. Plus blank. So you'll have n plus 7 squared. And 7 squared is 49. So you'll add 49 to both sides. So you get 2. Oh no, sorry, that's going to be 309. And if you do quadratic formula, you'll get 309 under the square root. Well, actually, you might not, because it might simplify, but if you simplified it, it would. So we'll get n plus 7 equals plus or minus the square root of 309. And then the last thing you would do is subtract that 7, so you'll have negative 7 plus or minus the square root of 309. Or do quadratic formula. That works too. If you prefer it. So negative 7 plus the square root of 309 is going to give you n equals 10.578. If you subtract there negative 7 minus the square root of 309, you get negative 24.578. Does that answer make any sense when you're talking about selling houses? It does not. Sorry. So this does not make any sense. 10.578 is your answer. However, you can't sell 0.578 of a house, so you need to sell 11 to have at least your. Now, I realize that one took a little while to solve, right? So if it's something really small like this and it's multiple choice, you're probably better off doing it the long way, although it's probably shorter. Just by adding up and say, oh, first house, second house, third house, fourth house, fifth house. Oh, on the 11th house, I made it to 65,000. past $65,000. So that's probably better to do in this case. If it's bigger numbers, if it's something like, let's say this was something that you could sell part of. Let's say instead of talking about houses, we're talking about like, you know, I don't even know, thousands of barrels of oil. Like if you're working at an oil company or something, you could sell part of thousands of barrels of oil, right? Something that you could sell part of, you would need to give a more exact answer probably for that. But if you are looking at this problem and you see the answer choices are, you know, 8 houses, 9 houses, 10 houses, and 11 houses, just figure up how much it is for each one of those and see which one gives you at least 65,000. But there can be others that you actually have to do this for. And if they may have asked something like, you know, where it's not in context, where you have to work backwards for this. So sometimes you might have to do that. But I'm perfectly fine with you doing whatever way is easiest whenever it comes to quiz and test time for these. All right, we're going to skip 7 for right now because 7 is just like the first part of the one we just did, and I want to make sure we get through this and you have a little bit of time to work on these. So we're going to skip 7 for right now. Geometric sequences. Geometric sequences, I think, are a little bit easier because the formulas only rely on the R and the N. You don't have to put like formulas inside of formulas for this. So a geometric sequence is a sequence formed by multiplying the previous term by a constant. And the R, the common ratio here, is the constant you're multiplying by in the sequence. So if the equation for the nth term of a geometric sequence is going to be a sub n equals a sub 1 times r to the n minus 1. Okay, so like I could have done this. I could have given you this problem before I even asked you to look at that formula. I could have said find the 28th term, and what are you doing each time? Here to go from 8,000 to 4,000 to 2,000, what are you doing to each number? You're dividing by 2, so you could just keep dividing by 2 until you get to the 28th term, and you could give me that number. However, it's going to be a little quicker to use the formula on this. Plus, you don't have that as quite as much room for error. So if I'm looking for a sub 28, I would take a sub 1, which is 8,000, times r. Now here's what's a little bit tricky. For a geometric sequence, it always has to be multiplying. And Skylar told me here that I was dividing by 2. But I can't use 2 as my r here because I was not multiplying by 2. What was I multiplying by? What's the same as dividing by 2? I'm multiplying by 0.5 or 1/2, whichever one you want to use there. So you've got 1/2 to the 28 minus 1. So in your calculator there, you're typing in 8,000 times 0.5 to the 27. And you should get for this 5.960 e negative 5. So it is common with geometric sequences to either get really, really, really huge numbers or really, really, really small numbers. Because if you're multiplying something by a number, it's going to get large really fast. Or if you're dividing by a number, it's going to get small really fast. So this, if it's written instead of a scientific notation, it would be, let's see, we'd have to move that decimal place 5 places. So we'd have 1, 2, 3, 4 zeros, and then 5,960 if you give it as a standard number. Okay, questions on this? All right. So our last problem that we're going to do is we're going to find the sum of a finite geometric series. And you'll notice there's one more formula down there. Right here we have our S sub n. It's the second formula under geometric series on sequences and series on your formula sheet. That bottom formula we are going to use tomorrow. Well, actually, not tomorrow. Thursday probably. So we're not using that one yet. A finite geometric series is only the first, so however many terms. Not a sequence that not a series that goes on forever, just the first, in this case, 10 terms. So what I think is a little bit easier about this problem is that you've got your a sub 1, you've got your r. There's no like a sub n that you have to plug in for this. So if you know your r and you know your first term, you can figure this out pretty quickly. So what in this case is our r? What are you doing? What are you multiplying by each time to get to the next term? Okay, not quite, almost. You would be correct if all of those were positives. But are they all positives? They are not. So it is -3. Because if you do 16 times -3, you'll get -48. But if you do -48 times -3, you'll get +144. And then if you get positive 144 times -3, you get -432. So if you ever see the signs alternating between a negative, positive, negative, positive, negative, positive, your r is a negative number because it's going to alternate back and forth. So in this case, our sum of the first, it's black here, our sum of the first 10 is going to be a sub 1, which is 16, times 1 minus r, which is -3. Make sure you put that -3 in parentheses, to the 10th power, all over 1 minus the r, which is -3. Okay, I think it's hard to type all that into the calculator at one time, so I usually do pieces at a time. If you do 1 minus -3 to the 10th, you're going to get, let's see, you'll have 16 times -59048 over 1 minus -3 is going to be 4. So then, if we do that, we've got 16 times that big negative number divided by 4 is going to give us -236,192. Okay, questions? Okay, the assignment that I'm going to give you is kind of long, but this is what I'm going to do. I do want you tonight at least do some of this. Don't just, and you've got time to start on it right now. Because of AP exams, we've got people gone. Tomorrow we're pretty good. I think Sydney's the only one that's got to be gone for something tomorrow. Wednesday, almost everybody is going to be gone, or a huge chunk of you. So I'm going to give you this assignment. I'm not going to make it due until Thursday. Okay? But let me tell you, tomorrow you will have more homework added to it. Okay? Because we're going to cover another unit tomorrow. Most everybody's here. We got to cover it, right? So what I'm going to do this week is you'll have homework from tonight. You'll have homework from tomorrow. I'm going to check everything on Thursday. That way, if you know you are going to be here in class, that you can use that time on Wednesday to do some of this work. So I would still do a little bit of it, but that way those who are here Wednesday have that little bit of time to do that. But if you're not going to be here Wednesday, I would suggest going ahead and doing most of the homework tonight. Homework tomorrow is not quite as long as the homework tonight. And then, you'll be good for Thursday. So the homework is going to be page 763. You're going to do 17 through 37 odd, 43 through 47 odd, and then number 52. Okay, all of those are going to be arithmetic sequences because our book does these in separate sections. And then page 771, you're going to do 17 through 23 odd, 27 through 33 odd, and then 37, 39, 43, and 46. And I will check this on Thursday. Although if you put everything off till Wednesday, you're going to have a ton of stuff to do. So I'd try to get some of it done. Okay, questions?